this is the question that a lot of you in Algebra 2 are struggling with. And what we're having, what is being asked of you guys is to understand where the axis of symmetry is. So that's the first question. That's the first question. And then you want to find the vertex as the second question. These are the first two. I'm going to do them first. So when we're finding the axis of symmetry, what we actually want to do is find the vertex first. And we have to look and wonder, how do we find the vertex? Well, the vertex formula is going to be b over 2, it's actually negative b over 2a. That's the vertex formula. And where do you get b and a? Well, that's from our original equation. So this formula is written out in its state with variables as a squared plus
what is 2 squared?
bx
both
plus c, or ax squared plus bx plus c. So we can apply these variables down here and insert them in the formula. So x, or the 1x, right? That 1 is going to be a. So that's a.
Now we solve, because remember
this negative 4 in front of the x is b, and this 5 is c. So then we apply it in our formula as negative 4 divided by 2 times 1. Does that make sense? Okay. Then we can do the math, which is going to be equal to negative 4 over 2. And when we have two negatives being multiplied to one another like these are, those automatically cross out. So it's just 4 divided by 2. When we do 4 divided by 2, that's going to be equal to 2, because 2 times 2 is 4. So 2 is the x-coordinate of our vertex. 2. Now we have to get the y-coordinate of our vortex. How are we going to do that?
Okay.
Well, since we have the x-coordinate, we're going to actually just insert the x-coordinate back into the original equation. So we can do that over here. We have f of 2 is equal to 2 squared minus 4 times 2 plus 5, if that makes sense. Then we're going to do the math. Negative 4 times 2 is negative 8 plus 5. And then we have 2 squared is 2 times 2, which is 4. So we have 4 minus 8 plus 5, which is all going to be equal to 1. So that is going to be equal to f of 2 and or y, which is the same as that. So then we go back into our vertex, and we just got it as 1. So our vertex is 2, 1. Now, how are we going to get axis of symmetry from our vertex? I hope this makes sense. I'm trying to make it make sense. Well, say we're graphing it, right? Our vertex would be at 2, 2, 1. So our vertex would be right there. And since this is a positive equation with a positive 1 in front, positive 1x squared, I can assume that our parabola, which is the curve, is going to open upward. If this was a negative x squared, then it would open downward. But this is a positive x squared, so it's going to open upward. I'm just assuming right now it's going to look something like that. Now our axis of symmetry is where the slope switches from negative to positive, or positive to negative. It is the point in which the slope changes on a parabola. That would be found at the lowest point. If you're imagining this, you're going down, and then right when you hit that vertex that we just found, you're going to start going up again. So our axis of symmetry, which is going to be a line straight up and down, needs to run right in the middle of that. So we're going to have our axis of symmetry, which runs right in the middle of our vertex. And if we wonder where this line is, well, it's at x equals 2. So our line of symmetry is straight up and down at x equals 2, which is also the first coordinate in our vertex. So our axis of symmetry is x equals 2. Now, the next questions you're being asked are, what are the x-intercepts? This is also really important. The x-intercepts are going to be wherever y equals 0. So if you imagine another graph here, where the graph intercepts with x, y is going to be 0, right? Along this line, which is x, y is 0. So wherever x-intercept is, y is going to be 0. So we can plug that into our equation as well. We can go 0 equals, and then put our equation, which is x squared minus 4x plus 5. And you're going to have to come back to watch how we're going to get the x-intercept from this equation.